Hi, hello, vanakkam. This is our sixth video of Leet Code 100 top regular questions, and today we are going to see 432 find all anagrams in a string. The description is given two strings S and P, return an array of all start index of P's anagram in a S. You may return the answer in any order. Okay, if you know the anagram, just skip it, and if it doesn't know, then you can read it. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original characters exactly once, which means that we have this string, and this is the anagram string. This anagram string can be in any order but exactly same character count. For an example, here you have ABC, and here we have CBA. So this is the same exact count, so it should be same. Then we call it as anagram. This is two strings actually, S and P. S is the original string and P is the anagram string. And output we can expect an list of numbers. The list of number contains that index of where that anagram starts. Okay, so in this case we have anagram at the 0th index and 6th index. Okay, I will show it on analysis page, and you will get it easily. This question comes under medium category. Okay, we came to the analysis page, and in this page we have two strings, right? I have written that, and we have one anagram string that's here. Actually, it is comes under sliding window. So as we saw yesterday, that same problem and same method we are going to solve it. So we are going to have two pointers, and based on the two pointers we'll move both the pointers same direction. As we said, we're going to initiate everything first of all, right? So I'm going to have two pointers, both the pointer going to start from the first index. This is 0 1. We have 9 strings, and these three anagrams we're going to store in hash map. This hash map going to contain the number, how many count it has. B is 1 and C is 1. Okay, these are our count. Yesterday we checked P1 as well, but in this case we don't need to check P1. Directly we can check P2. So P2 points C. So if it points to C, then we are going to look into the hash map. If this hash map contains the value, if this hash map contains that character and it contains value, if it is not 0, then we can reduce one element, one number, we can reduce one count, and we can move this P2 one step forward. We moved, and B is there. Then same again, B is there and it has a count, then reduce it and move this one step forward. I can see A in this hash map, so we can reduce the one count and move this one step forward. But here is one trick, here is one check actually. Okay, we'll write our check here. First of all, what we checked: if P2 in our set bank, P2 in our set bank, and it has count set bank, and P2 has count, it should be more than 0, then we came inside, right? So what we did here, we checked this condition and opened that set bank value. Once we found, then reduce one number from that. After that, we should check the count as well. Count means this count, anagram count, and P2 count, P2 and P1's difference. For an example, here our anagram count is 3, and Meanwhile, P2 minus P1 is it's 2, right? So okay, here we have if condition. This if condition checks that count of anagram and equal P2 minus P1 plus 1. Okay, so in this case P2 would be 2 and P1 is 1 plus 1, sorry, it is 0, and here have 2 and plus 1 is 3, so it matches. So if it is matches, then we can add the value into our result set. Append, just add P1's value. Okay, once we have added, then you can do the increment. P2 plus 1. Okay, I'm just incrementing the P2, but in this case we just need to take value. Yeah, we just need to take value whenever P2 minus P1 should be lesser than anagram's value, right? So that should be another condition. I'm just writing here P2 minus P1 should be lesser than anagram count. Okay, this condition should be added here, and yeah, now we can move on. P2 comes here, set bank P2, reducing it. A1 already has reduced, and I'm checking the if count is equal P2 minus P1 plus 1, so it matches. Then we are adding the result. I'm adding one value, P1 is 0, and I'm incrementing P2. Once I have incremented, then it's coming to 4, right? So in this case, this if condition don't work, because we have a check P2 minus P1 count should be greater than that, right? So this condition wouldn't satisfy, so we don't come inside. So we need another condition for it, a value which is not present in the hash set. Then we should do another set of process. So I'm making an elif, and we have an elif. In this elif we are checking that two things. When P2 is not matches, when P2 is in matches in our hash set, P2 not in set bank, and another check, P2 is present and it has value, it has 0. P2 in set bank, actually here it should be OR. P2 in set bank and set bank value is lesser than, no, actually, yeah, value is lesser than 0, not lesser than 0, equal to 0. If it is equal to 0, then it should come in this elif. Here we move P1 instead of P2. P1 currently stands at C, so I'm going to return a value to the hash set. Now I have returned it. Now I'm moving this P1 pointer one step forward. P1 set bank P1, and I'm incrementing 1, then P1 plus equal to 1. I have incremented it. The same step continues again, and this if condition doesn't execute because set P2 is not in the set bank, so we don't go inside. P1 is present, and we are returning the value to the hash set, and moving this step one step forward, P1, and same again, P2 is not present in the set hash set, then we are moving this one step forward. Now we have reached E. currently we are standing at the E. P2 not in the set bank, and so if condition won't get execute, and L is P2 not in set bank, so we are incrementing P1. So in this case we should add one more condition actually. This condition can be executed, but P1 cross P2, so it is not admissible to do. So we should add one more condition here. This condition should check that, should make sure that P1 is lesser than P2, right? And I'm making one more else. This check is performing like P1 equal P2. Whenever P1 and P2 at the same place, then it can move both the pointer one step forward. So I'm moving P2 and P1, both the pointers to here. Now again B is present, so it goes into the if condition and reduces one count. It's reduced. Now P2 is moving one step forward. A is there, and meanwhile I'm checking the count as well. Okay, and P2 P2 points to A. This A has one value and reducing it and moving this P2 one step forward, and again it comes to B. B is already 0 actually, it is present. As per the if condition, it is not satisfied. P2 is P2 in the set bank, but the value is in present. So it directly comes to the else, and we have two conditions here. P2 is not in the set bank, or P2 in the set bank but it has 0. Then we should move our P1. Yeah, this LF can be executed because it is 0, right? So it can be executed. Set bank, we are returning a value. P1 is 1. Yeah, I'm returning a value. P1 is 1. I'm incrementing the P1. I'm returning a A's value as well, and moving this one. Yeah, I'm not moving it actually. P1, right? I've returned it back. So I reverted the change actually. A is present, and now I have B, right? Now when the condition loops again, P2 I have a value 1 is there, so I can execute it. I'm making it 0, and I'm moving this P2 one step forward. It comes to A, but A doesn't have any value, so I need to move this value. I have moved it. Now P1 points to B. Now P2 points to A, right? P2 has a value right now, so I can reduce the value, and I'm moving this point one step forward. P2 is C, and C has a value, and I'm reducing it. After that, I'm checking the count. Count is matches. Then I'm taking this P1's pointer and storing into result. This is our output. We are correct. And finally, I'm moving this P1 one step forward. Before moving, I'm returning a value, and then I'm checking the P2. I'm just incrementing the P2. When I increment, it comes to D. It points to D. This D isn't available in the hash set, so we can skip it, and we can increment the P1. I'm returning A also, and I'm the P2 is still not present in the set bank, so I'm just doing the operation on P1, reducing it and keeping it 1, moving this P1 one pointer forward, P1. So here I have reached D, both are in same place, and here I would have one while loop. That while loop checks at P2, and P2 shouldn't cross this anagrams length, sorry, this strings length, original strings length, so we don't go forward, so we break out and return the result. Here we jump into our PyCharm, and I have our code and here I'm passing two strings and this is our anagram method. It takes two parameter, and I'm initiating two pointers, and I'm taking anagrams count and the total count of original value, and I'm initiating a set bank. This set bank going to be default dict, and if it doesn't know about default dict, it's just about it's just for adding a count, that's it. And result is a empty array. First of all, I'm adding all the set banks to my set bank. Sorry, I'm adding all the anagrams value, each anagrams character to the set bank, and then I'm taking a while loop. This while loop checks that P2 shouldn't make sure that P2 shouldn't cross total length of original string, and I have an if condition. This if condition checks that value P2 in set bank. P2 actually should be in the set bank, and that should have value, that shouldn't have 0, it should have at least 1. Okay, then you can go proceed with this if condition, then otherwise not. And there is one more check. This checks that it checks that P2 and P1 difference should belong to anagrams length, and I'm reducing a value from setbank and checking the count. If it matches, then I'm adding a value to the result, and then P2 I'm incrementing a value of incrementing a index of P2. Then elif, this elif checks that P2 is not present in setbank, or it is present but doesn't have a value. And one more check, P1 should belong to P2, it shouldn't equal or greater than to P2, so we should make sure that. And here I have a setbank. This setbank checks that P1 this setbank adds the value, incrementing the value of P1 and incrementing pointers, P1's pointer one step forward. And I have one more if condition. This if condition checks that value of P2 not in the setbank, and P1 equal P2, then we can increment both the pointers. Finally, we can return the result. This time complexity is order of n plus m. N means we can take it as a values length, and m means anagrams length. We have addition symbol because this we are running in our different loop, and this we are running it in a different loop, so we have plus. Then we have a while loop, and it just going through full length of val original string only once, so we have it as n. Then space. In this result, we are storing n number of value. This n number of value can be part of string, part of a original string, right? So it is n. Okay, we'll just copy this code to the Leet code and I will verify. Okay, I have pasted. I will run and check. Yeah, it works. It accepted, and submitting it. Yeah, it is accepted. Okay, I'll just copy this code on my GitHub repository and share the link at the description. Meanwhile, I will share the problem URL as well. That's it for this video, and I will meet on next video. Thanks. Bye.